Okay, so here's another example of a buffer solution that then we are going to add 5 milliliters of 4 molar NaOH2. So the question says a buffer is made by adding 0.300 moles of CH3COOH, that's acetic acid, and 0.300 moles of sodium acetate to enough water to make 1 liter of solution. So that's how I know it's going to be a molarity of 0.3, and the pH of the buffer is 4.74. That's good for us to know because it's going to help us understand, how much different is that pH after I add the basic solution. So remember that these are done in two parts, right? There's the BCA and then ICE. The BCA is done in terms of moles, and it is whatever we're adding. In this case, we're adding the base, so therefore we would show it reacting with the acid. So the balanced chemical equation, I'm just going to break this down into two parts here. The balanced chemical equation is the base that I'm adding, right? So here's my OH minus, and what is that going to be reacting with? Of course, the acid. So I'm going to be plus CH3COOH, and then full arrow, and that acid will be donated to the base to make water and that acetate ion. So once we have the balanced chemical equation down, we go ahead and fill out the before change equilibrium. So before, the problem tells me that I have 0.300 moles of my acid and 0.300 moles of my conjugate base. And because it says, because it says 5 milliliters of 4 molar, right? 4.0 molarity equals moles times 1, 2, 3.005 liters. I get 0.02 moles. Remember, this is all done in moles. 0.02 moles of OH minus. And the whole purpose of my buffer is that it's going to react with the base in order to consume it all. So my OH minus will go down by 0.02. The acid will also go down by 0.02, and the conjugate base will go up by 0.02 moles. Of course, water doesn't matter. And the OH minus goes down to 0. The acetic acid is now 0.28 moles, and my acetate ion is 0.32 moles. Now, in order to finish up this problem, I need to do an ice chart with these quantities, but in terms of molarity. Now, it says that I have 1 liter of solution, and I add 5 milliliters of this base. So my new molarity, if I think of molarity, of course, moles over liter, it's going to be 0.28 moles over 1.005 liters. Just a little different, but that will make this guy to be 2.2786 molarity in acetic acid and 0.318 molarity in acetate ion. Now I go and I do my ice chart with the acid acting as an acid. CH3COOH, that's acetic acid, reacting with water, donating a hydrogen to water, making H3O plus, and leaving the acetate ion, right? Ice charts are done in terms of molarity. My weak acid is 0.2786 moles. Water doesn't count. H3O plus starts out as 0, and this is 0.318 molarity. Minus X plus X plus X. Of course, this being a weak acid, the X is negligible, so 0.2786 X 0.318 molarity. And getting down to my end, my Ka is 1.8 times 10 to the negative 5. That equals the concentration of the H plus times the concentration of the conjugate base over the concentration of the weak acid. X is equal to the concentration of H3O plus, and that's equal to 1.575 times 10 to the negative 5 molarity. Estimate what that pH will be, 4 point something. And yep, the pH is equal to 4.80. So this buffer was 4.74. I added some strong base to it, but after I added some strong base to it, the pH did go up, but only by 0.04. So the pH actually stayed pretty steady, which is the whole purpose of a buffer. Part B says, for comparison, calculate the pH of a solution made by adding 5 milliliters of 4 molar NaOH to 1 liter of pure water. So how am I going to do this? Well, as always, pH is the negative log of the H plus concentration, or H3O plus concentration. And pOH equals the negative log of the OH minus concentration. If I add this 5 milliliters of base to water, what will be the new concentration of the OH minus? Well, there's many different ways to calculate this, but if molarity equals moles over liters, right, 4.0 molarity equals moles over 0.005 liters. That means we got the same answer last time, 0.020 moles of OH minus. Now divide that by the new volume, 1.005 liters, and that's 0.019. What is that? That's the molarity of the OH minus. It's a strong base. It will completely dissociate. So pOH is the negative log of that 0.019. That comes out to be 1.70, which means my pH is 14 minus that, 12.29. So if I had added that same base to pure water, the pH would go up to 12.29. I only added it to my buffer solution. The pH went up a very slight amount. This is just showing that buffers do in fact work.